Okie dokie. Factoring trinomials part 2. Again, starting with the idea that we have this form, ax squared plus bx plus c equals 0. Reminding you that a is the number in front of x squared. It's not x squared, it's not x, it's the number in front. And if you don't see a number, like this case right here, you assume the number is 1. B, the value of b in bx, is the number in front of the x to the first power term. In this case, even though we can't see it, this is a 1, not a 0, because if it was 0x, 0 times x would make that go away, wouldn't it? So this is you have to assume that there is a 1 here, please. C is the value of, depending on how you want to talk about this, that doesn't have an x value attached to it or has x to the 0 power, because we all know x to the 0 power is 1 as long as x is not equal to 0. So, okay. Let's see where this goes. So the third case that we want to talk about tonight was case 3, where b is a positive number and c is a negative number, and b is positive 1, right? B equals positive 1, and c, of course, equals negative 12. Reminded that when a is 1, we can use this little rule here that we have x to the, I'm sorry, not x to the n, but x plus m times x plus n will be equal to this thing up here, where m plus n is equal to b, and m times n is equal to c. So let's try that. Let's see how that's going to work. So I'm going to start by opening this up here. If you don't mind, open this up here and take a look at what we might have here. Here's a clue. A clue here is that when we multiply two numbers, we're going to get a negative. So we're going to have a number here and a number over here. But if we're going to multiply them, what's true about the sign of the numbers if we're going to multiply them and get a negative? Either we're going to have a positive times a negative, which is equal to a negative, right? Is equal to a negative. That says negative, I swear it does. Or a negative times a positive, and that's also equal to a negative, right? So it doesn't matter what order I put them in for now, in the case where a is 1. So I have x plus something and x minus something. Now what I need to get is two numbers. When I multiply those two numbers, I get negative 12, but when I add them, we get positive 1. Here's a clue. The numbers are going to be pretty darn close together because the difference of them is going to be 1. Can you see what it's going to be? Well, let's say that we know it's 3 and 4. If I put the 3 here and I put the 4 here, what would happen? Well, let's take a look. Let's do the outside part first. 3 times negative 4 indeed is negative 12. That seems like really good news, doesn't it? But negative 4 plus 3 is not positive 1. So what do we have to do? We're not in big trouble here. We just have to make a little switch. Take this out and make this negative and this positive. Go back and check it again. Negative 3 times positive 4 is still equal to negative 12 here. And 4 minus 3, or negative 3 plus 4, however you want to do that, is equal to 1. We can prove this by foiling this thing out. And if we foil it, of course, we would just do this. And I'm going to leave you to do this on your own, but I'll diagram it for you. Here's foil. First, yes, outer, inner, and last. All right, and I think that if you go ahead and do that foil, you're going to find that works out perfectly for us. Again, let me reiterate this for the 1,000,000th time to everybody, that I'm especially concerned, like when you take the SAT or something, sometimes they're going to ask you to solve something, sometimes they're going to ask you to factor. These are not the solutions. These are the factors. These are the factors. And if you're asked to factor something and you solve, you've made a mistake. And if you're asked to solve and you stop at factoring, you've made a mistake. So these are factors. And the two factors are, first factor is x minus 3. The other factor is x plus 4. All right? All right, moving on to the next case. The next case is this one. The next case is that, so let's call this case 4. Like an attorney tonight. Case 4. In case 4, b is negative. B is negative. And C is also negative, is C is negative. So that gives us something to work on there. And here's our problem. Our problem is that we are being asked to factor. We're being asked to factor x squared minus 7x minus 18. The book, again, does not set it equal to 0, but I always do. So if you don't mind, I'm going to do that just out of habit. First thing I'm going to do is, again, we're keeping in mind here that we do have, whoa, that's really cool. I've seen that. Sorry. We have ax squared plus bx plus c is equal to 0. All right? All right. So we're going to multiply two numbers. Well, let's do this. A is 1 here, so we know that we're going to start off with this, aren't we? Right, because in FOIL, right, you have FOIL, F-O-I-L, FOIL. The first part, this times this, gives you exactly this. And the last part, this is what's great about FOIL, the last part gives you exactly that. The O and the I part is where it gets a little bit gamier, but okay. So we know that we're going to have a positive. Whoa, 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 I'm not even sure that's the right number at all. Wow, it's really weird. We're going to have a positive times a negative, aren't we? So we need factors of 18 because of 18. So 18 is the same as 1 times 18. 2 times 9. Look at that for a second. 2 times 9. Why does that mean something to me? Because I'm going to have a number minus a number, and 9 minus 2 is positive 7, and 2 minus 9 is negative 7. So that gives me a clue. Which number goes where? Well, we want the middle term to be negative, so we want the number that's farthest from 0 to be the negative number. So we're going to have negative 9. So negative 9 here, isn't that right? I'm going to go back and check this, just so you know. It's not like I'm just guessing, and I'm not going to go back and make sure. I was talking to somebody today, and they said they're constantly making really dumb mistakes, and when they go back to their quizzes, they're like, God, I don't know how I screwed that up, and I just rushed through it. Well, you do know how you did. You rushed through it. Take your time. This is important stuff, so take your time doing it. Let's just try this part here to see if this works. Positive 2 times negative 9 is in fact, right, is in fact this value right here, isn't it? And negative 9 plus positive 2 is in fact negative 7x's. It worked, didn't it? How, right. What is it you think I'm about to tell you? Because you're right. I'm going to tell you that these are what? Are these solutions? No, these are factors. Then I'm going to tell you how can you check your work to make sure you got your answer right? Easy. Just use FOIL, right? And I'll outline FOIL again for you. First, outer, any other cool colors? Inner, last. Okay? All right, so I think that gets, we have a minute and a half left, and I'm going to use it, I think, so bear with me, because I just want to show you one more thing that could happen. Sometimes we don't have to use the factoring technique that we're using right this second. Sometimes we just factor. We just factor something out. So let me see this one here. And when I did this problem today with a student, he was like, isn't it the same thing as this? And it is. So how about this? X squared minus 7x. And you're being asked to factor that. And the way I did it was this. I just hooked this up like this. And then I just realized, look at this. It's pretty stark here. This has at least a factor of x, and this has at least a factor of x. So I'm going to factor an x out. And then remember, we have to recreate this. So x times what is x squared? Well, x times x is x squared. And x times what is negative 7x? And it would be negative 7. Again, would this work? Let's go back and check. X times x, x squared. X times negative 7. And what are these? Again, these are the factors. Okay, I think we covered that. Good job, you guys. Really, really good job. Keep up the good work. Practice. That's what makes perfect. Practice. I should practice singing. Or I can